Hi guys, in this video we're going to have a look at something very similar, but we're going to solve a quadratic when it's a negative coefficient of x squared. So when it's solved, you can deal with this in a slightly different way to if you were factorizing. So basically you would normally make this positive, and you can do that by putting everything on the other side. So I'm going to do that. So I'm going to put everything on this side. Now, it's not a square number, take away a square number, so we know it's not difference to two squares. And because we have this value here, that's going to make everything a little bit more confusing. So I use what I call the AC method. Some people call it just the quadratic algorithm method, whatever you want to call it. But you look at the factors of 6 that make 5, and this one's tricky because you've got two options that make 5. You could do 6 take away 1, or you could do 2 add 3. So it's very important you look at this one here now, because that's a negative 3. You know the signs, they have to be different, because when you find the product of the last two terms in the brackets later, you know what I mean by that is this term here and this term here. When you multiply those together, they have to be negative, they have to equal -3. So we're going to actually use this one here. And we do a rewrite of this coefficient of b, but using these two. So I'm going to keep it all nice and tidy. So plus 6x minus x minus 3. Now what a lot of students do, they lose their structure here. My inequality signs in a nice line, just like your equals would be normally. And just take your time with it. So we're going to factorize these first two terms. So we get x plus 3. And you'll notice by looking at the next two terms, there isn't really well, there's only one common factor, and that's 1, which we don't normally factorize for, but in this method we actually do. So that's a minus, so you can always just take that out. And actually, what I like to do is you should have the same bracket. So if you pop that bracket on every single time and just expand it and see if you get what's above. So there's minus x. Sorry about that. There's minus x, and that's -3, so it works. Now if you pop the repeated bracket on and it doesn't work, then you've gone wrong. You might not have taken the highest common factor out here, or you messed up this section. Okay, so you know this shouldn't be new to you anyway, this method. So we've got 2x minus 1 and x plus 3. It's our highest common factors in the one bracket, and the repeated bracket is our second bracket. Okay, let's find our critical values, because we've got an inequality. So that's my mindset every single time. Inequality, find my critical values. So x is a half when 2x minus 1 equals 0, and x equals -3. Now, I manipulated this to suit me, but the question was this function here. So, and if you've done transforming graphs, which you might not have done up to this point, you'll realize that this is just a reflection of this graph, so the root values will actually be the same. But I manipulated that to help me solve it easier. So let's make a critical value sketch. So we've got -3, and we've got a half. And this is an unhappy quadratic, so we're going to sketch it this way. And this is very important, because if you sketched this one, which is again a manipulation of that to help me solve it, you're going to get this next part all wrong. So it says, where is this function less than 0? This is the line where the function equals 0. So this, below this line, is where everything is less than 0. So we are looking for that part there and that part there. So when x is greater than a half, so we can put our set notation on there. X is such that x value is always greater than a half. And we've got x is less than -3, set notation, and we unionize those because it can be here or here. Now please note, if this sign was the other way, then we'd be looking at this. So it's not as simple as going, oh that's less than, it's below the line, or you've got to look at your sketch and don't get caught out if it's unhappy.